Maybe Desmos knows what we don't know, and in fact, in the latest SAT exam, it has been proved. Many students found some tricky questions on regression and other functions really challenging, but then they turned to Desmos and they cracked the answers with ease, and that is the real power of Desmos. So in this video, I'll begin this with a quick introduction to Desmos, show you how you can adjust some basic settings, revisit a question we started in the previous session, and then dive into the solution of a few more set style questions, right? Okay, so let's start. Here we are. Where is our question? Yeah, that is our question. If you see the previous lesson, actual equation is y is equal to 20x plus 50, where it is the situation of a gym membership, right? 50 is the initial fee, registration fee one has to pay to register to the gym, and 20 is the fee for per month, right? That means this x will go one by one. First month, second month, third month, fourth month. So let's see how I can put it on graph. 20x plus 50, 20x plus 50. Now you see, if I just want to see the y-intercept, it is too far. I have to scroll a lot to reach to 50 because it's going by 0, 4, 6, 8. Now I can either zoom in or zoom out, but then x and y both will change. So I want to keep x as 1, 2, 3, 4 because these are the number of months and I don't want negative values. And I want to change y with 50 or maybe 25. So let's see how we can do this. This is the settings button. Just press this. Let's start with -1, right? And then I want steps of 20. See, it will not show 25 right now because y is coming with 3. So let's make it. Maybe 250 is the maximum cost I want to take. So see, now it is in range. But I want to do with the basic step of 50. Let's see. It's easy to change. We will change it one more time. So step 50. Okay, now it is making much more sense. Everything is in front of us on the paper. Now if the question comes, after 4 months, what will be the total cost of gymming? So I do not have to plug in or everything. I'll see, because months is on the x-axis, right? And cost is on the y-axis. So if question says 4 months, that means 4 is given to me. So I'll just come here. Okay, so 4 months, for 4 months cost will be 130, right? This is the answer you are getting quickly without putting your pen. Okay, without picking your pen, I'm sorry. Now our question says, what does the point 0, 50 represent? Okay, what equation? If the equation is graphed with m on x-axis and c on y-axis, what does the point 0, 50 represent? This is the general concept question. Initial value is 0. So that means y is equal to 20x plus 50. So when x is 0, y is 50. And that means 50 is the initial value or the registration fee. On the graph, what does the point 5, 150 represent? Now it is written in the form of coordinates. That is why the question is asking you to check it from graph. But if we see the actual information, x coordinate is about number of months and y coordinate is about how much cost one is going to pay if he is gymming for 5 months, right? So 5 and 1 or x months. So if he registers for 5 months, total cost he has to pay 150. That is the general concept question. Now when this question comes, after how many months will the total cost exceeds 300? If you do it by algebra method, so cost should be greater than 300, 20x plus 50, and you have to find number of months for this. But if I use this one, cost has to be more than 300. Now if you can just do it from here. It has to be more than 300. If you just slide, 300 will go with it like this. So here is this 300. Now let's check. That is the point. I do not have to see the months. I can see the coordinates, right? So it's 300. Okay, that is 300. For 12.5 months, it's going to be 300. But the gym does not offer, memberships in fractions or decimals. So if the cost has to be more than 300, then number of months should be 13. So see, you are not solving anything on the paper, but even then solving it correctly. So it saves a lot of mental energy as well as the time. Now let's see some other questions, right? Okay, let's cancel this. Now the graph is as it is. So here we are. And now let's see what. Okay, let's take one question. Let's say we have two equations. See, it's always like favorite of SAT, proper SAT type question, when one of the equation is given in slope intercept form and another equation is given in like standard form. So let's say first equation is 2x plus y is equal to 12. 2x plus y is equal, let me check it. Yeah, it's good. And the second equation is, let's say y is equal to x plus 1. So y is equal to x plus 1. Now these are the two equations. Graph is already drawn. It's going out of sight, so let me just zoom it a little bit. Make it visible. Okay. Difference of 0.5, maybe the difference of 1. Now because x and y both are going, oh, that is the problem. It's 0 to 50 to 100, 100. So now these are small numbers. So let's make some settings. Let's go with step 1. And this also is up till 10. No, minus 98 is not needed. Let's do it minus 1 point this. Now the two lines are clearly visible, right? So the question can be, what is the common solution to both? If you take paper and pen, you have to solve it by substitution method or any method. But here you can just simply say that is the point of intersection of both. Okay, what is the point? Just find it. This is the point, right? Now if says what is the integral solution, so you do not find this point on any of the integers, right? This is in between two values and this is in between two values, so that is not integer. So if your question is like what is the integral value for this system of equations, so you solve it and you get the answer in decimals and then you say, oh, no integral solution is there. But if you draw it on Desmos, it's like just a click away. Your answer is just a click away, right? Okay, let's take another question. Let's say, okay, that is about integral solution. Now next question is 2x plus y. Let's make 10. And y is equal to x plus 1. So what is the common solution for both? No calculations, no time spending, 3, 4 is the common solution. So I'm just like asking you to try to use Desmos whenever and wherever possible. Initially, maybe you will find it, no, it's like not easy to use, but once you start using it in your practices, you will find it's a real game changer. So I hope you will try that and every concept is clear.